In this video, we're going to apply L'Hopital's rule to find the limit of an indeterminate form produced by a quotient of the form 0 divided by 0. It says evaluate the following limit using L'Hopital's rule. It says limit as x approaches 0, 13e to the 5x minus 13 over 8 sine of 2x. So let's just make sure that this is actually 0 over 0. If I put 0 in here, that'd be e to the 0, which is 1. 13 times 1 is 13. When I subtract those, I'd get 0 on top. Plug 0 in here. Sine of 0, because that'll cancel out the 2. Sine of 0 is 0. So 0 times 8 would be 0. So this is indeterminate. Now we're going to use L'Hopital's rule and apply it to this limit. So we're going to say the limit as x approaches 0. And then we're going to take the derivative of the numerator, and we're going to take the derivative of the denominator. And when we take the derivative of the numerator, we're going to get the limit as x approaches 0. So the derivative of e to the 5x is 5e to the 5x using the chain rule. Derivative of e to the x itself is just, it stays the same, but I have to do the derivative of the inside function, which would be 5, and that's why I have a multiplication of 5 out front. So this 5e to the 5x needs to be multiplied times the 13. So 5 times 13 should be 65, so I have 65 e to the 5x. And then derivative of negative 13 is 0. Derivative of 8 sine 2x. So the derivative of sine 2x is equal to cosine 2x times the derivative of 2x, which derivative of 2x is 2, so you end up with 2 cosine of 2x. So I'm going to go ahead and write 2 cosine 2x, but I have to multiply it times 8, so it's actually 16 cosine 2x when I take that derivative down there. Now let's apply the limit. So 0 goes in, I get 65 e to the 0 over 16 cosine of 0. That equals 65. Because e to the 0 is 1. Cosine of 0 is also 1, so that'll be 65 over 16. I'm not sure that reduces. Let's double check here. It is 65 over 16, so I'm going to call this my original function, so this is f of x right here. So I'm going to say that the limit as x approaches 0 for f of x is equal to 65 over 16. And that's an application of L'Hopital's rule.